Hey, welcome to this little video presentation about closures in Swift. So, what are closures? We can think of closures as a kind of little nameless functions. In this presentation, we are going to take a closer look at what they are and how they can be tested. We will start with an example to set the scene and then see closures in action. Let's start with a simple function that adds two numbers. It takes two integers as parameters and returns the total. Let's move this function inside a class named myService. Now, let's call this function, pass it two numbers, and put the result in a variable called total. We would usually want to do something with the total. In this case, let's just print it. Now, let's put this code inside a function and put the function inside a class. This class needs an instance of myService, which needs to be declared as a variable. We initialize it within the initializer. Now, how do we test doStuff? For example, how do we test if doStuff actually calls addNumbers? First, we need to put myService behind a protocol. A protocol is what is known as an interface in some other languages. First, we need to declare the protocol. Then we declare that the myService class conforms to that protocol. Next, change the type of myService to myProtocol. Now, let's make a fake version of myService that conforms to the same protocol. The fake version is useful for testing because if someone calls doStuff, that would call addNumbers on myService, but myService is of type myProtocol, which is implemented by the myService class as well as the fake service. During runtime, we can pass in an instance of the myService class, and during testing, we can pass in an instance of the fake service class. We will see an example of that in a minute. When testing with the fake service, if we call myService.addNumbers, it would call the fake version of addNumbers. At the moment, the fake version of addNumbers isn't really doing anything useful. It just returns 0 all the time. So let's make it more useful for testing. We can introduce a variable to help us test if the method is called and set it to true when the method is called. We can also have a couple of variables to store the parameters. Then store the parameters passed into these variables. We can look at these variables to test if calling doStuff actually calls myService.addNumbers. And since during testing we replace myService with an instance of the fake service, this function will be called and these variables will be set. So later, by looking at these variables, we can test if the function has been called and what values are passed as parameters. Our tests will see if we have the expected values there. So everything is okay for a while. But as time went on, things changed. In this contrived example, people decided to move the calculations to the server side, maybe because they wanted to get ready for more complicated calculations in the future. So they started moving things around. They made a call to a web service to do the calculations. But now we have a problem. When we call this function, the function gets called. It calls the web service. Then you get stuck waiting. It takes a while. As this function waits, the function that called it is waiting for it to return. This could mean our UI is stuck, and the user might think the app is frozen. What if we don't wait for the result? Let's just kick off the web service call and return without waiting for the result. But if we are returning without waiting for the result, then surely we won't have a result to return, which means the function signature has to change, which also means the calling function gets no return value. Then how can we print the result? Because we don't even have the total anymore. So let us pull this out and put it in a different function. Now this function makes a call to this function, which is here, but it returns without waiting for the result. But we want to print the result of the calculation. For that, someone needs to call this function, ideally after you got the result. Maybe we could call the function like this. That would print the result. But wait a minute, how is it possible? How could we do anything after a function has returned? Let's ignore that for the moment. We will come back to that later. But for now, let's assume we have some magical powers to do something like this after the function has returned. Then we have another problem. How can we call this method here? This method is not from this class. It's from a completely different instance of a different class. The solution is to take this function and pass it on as an argument to this function. Let's call it callback. But while we call it callback, what is really being passed is the print total function. So instead of saying print total here, we just say callback. We still don't know how we could do something here after returning here, but let's ignore that for the moment. We are passing in the function here, but if we are not using this function anywhere else, then there is no need to define it here. We could define and pass the function in one go. In this case, the syntax is a bit different. For example, the callback parameter of the addNumbers function is defined here. Its type is a function that takes an integer as an argument and returns nothing. So here, we don't have to say again that it is a function. And since we are defining and calling this function in one go here, it really doesn't need a name. Now this is what we call a closure, a function without a name. In these nameless functions, called closures, the argument list is moved inside of the curly braces. And since we already know that the type of the input to the function is an integer, we don't need to say it here. And after we remove the type information, the braces are no longer needed. So if we reformat the code, it would look like this, where this is now an unnamed function. But how do we test this function? A function is like a machine. To test it, we call the function, give it some input, and check if the output is as expected. We have to do the same when testing this closure here, but it doesn't even have a name. So how do we even call this function during the test? Let's see this in action. First, during testing, the fake version of the My Service would be used by injecting an instance of the fake version through the initializer. So when we call the function addNumbers, our closure, the parameter named callback, will be passed to the fake version of the function. Our nameless function is passed as a parameter here. We could capture this function and store it in a variable. Let's create a variable to store it, and then store it. Now let's think about testing. Let's create a test method. Let's create an instance of my class. But this now needs something that implements the my protocol. Since this is a test, let's use the fake version. So let's create an instance here and pass it on to the initializer. Now let's call the function. As we call this function, it would in turn call addNumbers on my service. But my service is actually the fake service that we injected through the initializer. So addNumbers is called on an instance of the fake service. So this is the function that is called. But our original question is, how do we test this anonymous function? To test it, we need to be able to call it during our test. It is passed as a parameter here, and then stored into this variable, which is an instance property of the fake service class. You could access it like this. Since this property stores the nameless function, we can use this property to call the function. The property works like a function name. You could call the function and pass 5. We need a question mark as the instance property is optional. This is how we call that nameless function, the closure. Now that we have found a way to call the nameless function, the closure, we can check for the output. In this case, there is no output as the nameless function we are testing doesn't really do anything. Usually, it would produce some sort of side effect, such as calling other methods, for example, to make another network call or to update the UI, etc. We could test for these by using dependency injection as usual, inserting fake versions of those dependencies and then checking if those were called correctly. Here is one more little detail. The callback block here gets stored into this variable, which means the code inside that function would live on even after the addNumbers function has returned. Such closures, which are passed as parameters into functions and which have a longer life than the function they are passed into, are considered special in Swift. They are called escaping closures. They should be marked as escaping along with their type. The function signature in the protocol should have that too. We don't have to mark every closure that is passed to a function as escaping, but if that closure is going to be in memory after the function has returned, then we have to mark it as escaping. It is a requirement by the Swift compiler. In our example, this closure is assigned to this variable, which is an instance variable. So the closure will stay alive even after the function has returned. So this is an escaping closure. Now let's think about the doStuff function once again. At first sight, it might look like this print is happening inside this function, but actually it is part of this nameless function. So there are two different functions that are called at different times. So when this big function is called, it calls this function, and this function or closure is just one of the parameters passed to this function. So this block of code doesn't run here. It just gets packed up and passed on to this function, gets assigned into this variable, and gets stored here. So when this function is called here, it doesn't run this code. It just gets stored into this variable. And only when we make this call, it executes the stored function, which prints this line. This means this line executes only after this function returns. Now let's try to solve the mystery we mentioned earlier. It's about this line of code here. It somehow needs to execute after the function returns. Let's see how that is possible. First, a quick recap of what this code is doing. This is a function that adds two numbers. At first, we started with a simple version that just returns the sum of the numbers. Later, we made it much more complicated. It is now calling a web service to add the numbers. The web service could take a few seconds to respond, but we don't want our function call to be stuck for that long. So we said we will just kick off the call to the web service and return immediately, but at the same time, we somehow wait for the result from the web service. We then use the callback function to return the result. This callback function was passed by whoever who called this function. So the caller who called this function says, here are two numbers, add them up, and don't return the result the usual way as a function return value. Return the result using a new way. The new way is this. I'm passing a function to you as a parameter. You can use that function to return the result to me when you are ready. Just call that function and pass the result as an argument. So let's see how this actually happens. Remember, we are calling a web service. Let's see exactly what that call looks like. API service is some kind of a wrapper to the web API. We call this method and pass three parameters, A, B, which are numbers, and a completion handler, which is a function. Again, we are passing a function as a parameter and saying, call this function when you're ready to give us a return value. We define the body of the function here. The important thing to remember is that this function is not being called here. We are just passing this function as a parameter. So any code we put in the body of the function is not going to be executed at this point. So what happens if we put our call to the callback inside the body of that function? It looks like it's going to execute before we return, but remember, we are not calling this function. So no code is executed now. It is just passed on to the add function as a parameter. So the block of code in green is not really a part of this function. It is a completely different function. It is not called here. It is just defined here and then passed as a parameter onto the add function. After passing this function, which is a closure, over to the add function, we return from this function. This function, the closure, the callback block that is passed on will be executed later. When? That is decided by the API service. We have just passed it on to it. So we are saying, here's a function, you can call it whenever you like. And the API service will probably call it after waiting for the response from the network so that it can pass on the result. So at first sight, it might look like magic. The green block is executing after the function has returned. How is it possible? Simply because the green block is passed on to someone else. It is passed on before this function returns, and the receiver of the green block, which could be another function or object, can call it or execute it anytime they like. They are not limited by the life of this function. So here is a summary of everything we have covered here. So in Swift, as in many other languages, closures are used for callbacks with asynchronous tasks. Closures can be thought of as little independent functions. Like any other functions, they can be tested independently. But since closures have no names, they cannot be called directly. So a little bit of work is required to capture and call closures during testing. That's it. Hope you have found this useful, and thank you for watching.